this video, I try to print the number of unique paths in a matrix. Following statement: the input is n, the dimension of an n by n matrix. So when n is 2, the matrix will be 2 by 2. For a rule for this program, you can only go to the right or down on each cell of the matrix. And the output will be the number of unique paths from the top left corner of the matrix to the bottom right corner of the matrix. For example, when n is 2, the output is 2, because there are 2 ways to go from 1 through 4, and 1 to 4. Top left to bottom right. The 2 ways you could go from 1 and then 2 then 4 and 1 then 3 then 4, and they have to be unique. For one observation, since we only go right or down, there's only one way to reach the cells on the first row over here and the first column over here, and I'll fill up the dynamic programming DP table with 1 for first row and first column. So these will all be 1. For another observation, for cells other than the first row and column on the dynamic programming DP for short table, dpij is equal to dpij minus 1 plus dpi minus 1j. So when ij are 0, then dpij would be this, because there's 0, 0 on rows and 0 on columns right here. J is what column and I is what row. So when I is 1 and j is 1, then it will be over here. To figure this out, you could to figure how many different possible ways to get over here, you could do how many ways there are to get the adjacent left cell and how many ways there are to get the adjacent upper cell. So in this case it will be 2, because 1 plus 1 is 2. For cells other than the first round column, dpij is equal to dpij minus 1 plus dpi minus 1 j. This is the same thing, just this time it's showing off over here, because on the left is 2 and the upper is 1, then it's 3. For code illustration, function num of paths takes the input of n, which is 3 in this case, and the output is how many different ways it takes from top left to bottom right. It won't show the different ways. It will only show how many different ways, not the different ways. And then it'll make DP, the dynamic programming table, to be equal to n 0 for each row and 0 for each column. And so it'll make n zeros for one row, and it'll make n of those rows. So because n is 3, it'll make 3 zeros for each row and 3 of those rows. Then I have a for loop, which I flips to the column i's columns of each row, and yeah, I will go through i's row, and j will go through each one in that. I'll go through each column in that. And then when I is 0, the first row will be set to 1, because if I is 0 or j is 0, that means there's only one path to get to that point, so I'll make it 1. So I'll go through over here, the first row, and I'll make it all 1. And then it goes through into the for loop again. This time I is 1, and then since I is 1, it doesn't go in because of this, but because j is 0, it still goes in for this because it's part of the first column, so I'll make this 1. And then after j increments, then it'll be over here. And then because neither I or j is 0, it will go into the else statement, and the else statement will get the amount of ways it takes to get to there, which will be the adjacent left cell plus the adjacent upper cell. And 1 plus 1 is 2, so this will be 2. And then it goes in the else statement again, because neither I or j is 0, so it goes in the else statement again, and 2 plus 1 is 3, so it makes this 3. And then it'll go, I will increment and j will go back to 0, and because j is 0, it will make this 1. And then it'll go to the else statement, because neither I or j is 0, and then the left adjacent cell is 1, and the upper adjacent cell is 2, so I'll make this 3. And then it'll go in the else statement again, and the left adjacent cell is 3, and the upper adjacent cell is 3, so the output is 6, because this is the rightmost cell, so the 6 ways to get the rightmost cell in a 3x3 matrix. See how it works. 6. The end.